Assalamu alaikum. Welcome to Mathematics with Shahab Yaqub. In this S2 class, let's revise some topical past papers related to hypothesis. Now, when we talk about hypothesis, we are first focusing on the definition of hypothesis, and this is all done in our on-campus classes. Hypothesis, a theory, an idea which is assumed to be true unless proven otherwise. H0, that is the null hypothesis. H1, that's the alternative. I always give example of this particular train that is coming every 10 minutes. A commuter is suspicious. He has doubts whether the mean arrival time is the same or it has increased. So if it's increased, that is called an upper tail test. If it's a decrease, that's called a lower tail test. If he is unsure, that's a two-tail test. The tail is this and this. So increase, we focus on the extreme right. Decrease, we focus on the extreme left. And in a two-tail test, we focus on both the things. It's related to sampling. That is how Z is calculated. This is the cholesterol question that is done in class. And we did it through the X bar method also, and so on. Now, there are 4 steps that I focus on. That is basically jotting down the details of normal distribution, listing down the H0 and H1, stating the null and alternative hypothesis along with the significance level, calculation of Z, and then concluding. If the Z value lies inside critical region, we reject H0, accept H1, except that, what is it about? This particular question is about a new operator takes over the service. And the average time has decreased. So what have I written? Average waiting time. WT is the waiting time under the new operator has decreased. And now let's get started with some past paper questions. That is from your topical book, which is topic number 5. The first section, that is normal distribution, as well as CLT, that is central limit theorem, that is also normal distribution if the sample size is large. So if the sample size is large, it becomes approximately normal distribution. So now let's read this question. Let's underline it. Now I'm getting the highlighter ready. The mean mass of packets of sugar is supposed to be 505 grams. A random sample of 10 packets filled by a certain machine was taken and the masses in grams were found. And this is the mass of 10 packets. First part, find unbiased estimate of population mean and variance. So let me just focus on the first part. Get your calculators ready. And first of all, let me write over here, unbiased estimate of population mean is the same thing as sample mean. An unbiased estimate of population variance, it's n over n minus 1 sample variance. And I'll just show you the basic steps. If I add all these numbers up, I'll get sigma x. There are 10 of them. And hence I can calculate X bar, which is sigma X over N, which will give me the value of unbiased estimate of population mean. So unbiased estimate of population mean is this thing. Unbiased estimate of population variance is this thing. Over here, the sample variance, that is sigma X square over N minus X bar square. That means we will take all these values, individually square them. So 500 square, 499 square, 496 square, all the way till 494 square. Divide by how many they are? They are 10 minus the mean score. Minus the mean score, we will take the square of that. And then that is how S square is obtained. Once S square is obtained, therefore, sigma square with a hat, that is n over n minus 1, and S square, that's right over here. So let me get the details from here. Everything is written over here. Sample mean is coming out to be 504.5, 504.4. And the unbiased estimate, I did not calculate. It's right over here. This is another formula that they use. Now, let me also show you this particular formula. So let me go over here. Let me open the formula booklet, which is already open. And this is the formula that I was talking about for unbiased estimate. That is over here. So if someone wants to use this formula, they can use it directly. So let me paste it over here. And let me also show you this particular formula, how to use it. When we talk about unbiased estimators, so unbiased estimate of population mean, unbiased estimate of population mean, that is sigma x over n, an unbiased estimate of population variance. So let me use this symbol, that is sigma square like this, that is n over n minus 1 sample variance. So if you want, you can use this particular formula, which is 1 over n minus 1, sigma x square minus sigma x whole square over n. That means we would square each one of these 10 values. We have already added them up. That's right over here. This is sigma x square. Just use this formula and then you can get the direct answer. So over here, unbiased estimate is coming out to be 495.9, and this is, this one is the mean, 495.9, and this is 12.8. So this is 12.8, this is 495.9. That is how these two are obtained. All good? Now let me show you the working, and then we have some working with which we can check. Now, after this thing is done, one thing I would like to ask, that is, did it state that it was following normal distribution? I don't think so. Yeah. Explain why the use of normal distribution is justified. That is justification. In the beginning, it's not stated. So first of all, let me write this thing, the first thing, and then the next thing. That is, sample size is large. That is about 150 packets. Or let me read the question first. It says over here that the mean mass of packets produced by this machine was found to be less than 505. So the machine was adjusted. Following the adjustment, the mass of a random sample of 150 packets, so 150 is right over here, that's the sample size, from the machine were measured, and the total mass was found to be 75660. That means the X bar for this part is 75660 divided by 150. Get your calculators ready. I'm getting my calculator ready. So hold for a second. 75660 divided by 150, that comes out to be 50.4. That is my X bar. It says, given that the population standard deviation is 3.6, test at the 2% significance level whether the machine is still producing packets with mean mass lesser than 505. Now, what needs to be done? So let me make 4 boxes. The first box, and I just need to remove this thing, and let me put it somewhere over here. Okay, I think this is fine. Okay. So now this thing is done. That is the first box. And then the second box. And then the third box. And last but not the least, that is the fourth box. And let me also draw a normal distribution curve over here because we will be using it. Okay, I think this shape is good enough. Now, in the first one, what do we write? First of all, it does not say that it follows a normal distribution. So first of all, I'll say sample size. Sample size is large. Since sample size is large, n is greater than or equal to 30, therefore CLT applies. So it now follows a normal distribution. So X bar follows a normal distribution, mu, comma, sigma square over n, n is 150. How much is mu? Mu is 505. How much is sigma? That is 3.6 and square. We write a variance on the inside. And the sample value, which I calculated, that's right over here, 504.4. 504.4, that is the sample value. And it's at 2% significance level. So for 2% significance level, let me write over here 2%. And the Z value, I have labeled it to the left. Why? Because I should state the alternative and the null hypothesis. First, the null hypothesis, mu is 505. And it says less than. So mu is less than 505. Therefore, it's a one tail, lower tail test. And the significance level is 2% significance level. Now, for 2% significance level, this value is negative 2.054. So the Z value is 2.054 with a negative sign, and 0 is right over here. All thing good, all okay. Now we need to calculate the Z value. Z value, this is X bar minus mu sigma square over n under root. That is 504.4. That is right over here, minus 505, which is the mean, divided by 3.6 square over 150 square root. And this Z value is coming out to be negative 2.04. This is coming out to be negative 2.04. That is the Z calculated value. Now we need to check, does this lie in the critical region, yes or no? So this Z value is just outside of the critical region. That is the Z calculated value. And what is the conclusion? The conclusion is, do not reject H naught. In other words, accept H naught. And then we write it in the context of the question. It is about the mean mass of packets, the adjustment, and the total mass was lesser. The machine is still producing packets with mean less than 505. No, it's not. We have insufficient evidence to prove that after adjustment, the machine is producing packets with weight lesser than 505 grams. That is how you write it. So now this packets question is done. This is from before. And this is 2.04. We compare it with this. This is the 98% Z value, because 98% is to the left, 2% is to the right. That is how we get the value. And then the normal distribution curve, we have the negative 2.054 because it's a lower tail test. No evidence at the 2% significance level that machine packets mean mass is lesser than 505. And now the last part. It says, explain why the use of normal distribution is justified in carrying out the test. We already said so, that the sample size is large, n is greater than or equal to 30, CLT applies, so it automatically becomes a normal distribution question. So now this is question number 38, which I did. And let me write it in the group. So this is question 38, where is it? So question 38. And is it all good, all clear? Just acknowledge. So this is one group, and then there are two groups, other one. Okay. So now this is all good, all clear. Now this particular question, I would like you people to try it out. So let me just pause the recording. So now let's look at this question. First thing first, underlining. The mass in kilograms of rocks in a certain area has mean 14.2 and standard deviation 3.1. Find the probability that the mean mass of a random sample of 50 of these rocks is less than 14.0. The first part, it's about sampling. So part 1, X bar follows a normal distribution 14.2, 3.1 square. Probability X bar is lesser than, and also the 50, don't forget the 50. X bar is lesser than 14.0. Probability Z is lesser than 14.0 minus 14.2 divided by 3.1 square over 50 under root. Probability Z is lesser than a negative value. How negative it is? Let me look at the mark scheme. So this is coming out to be negative 0.456, 1 minus 0.456, 324. So 0.456, which is 1 minus, first of all, probability Z is greater than positive 0.456, which is 1 minus 5 of 0.456. And using the normal distribution table, which let me take it out so that we don't miss out on anything. And I think I just saved an image earlier for my S1 class. So I think it should be right over here. Yeah, there it is. So now it is 0.456. So let me go to 0.45. So this is 0.45 and then 6 in the same line, that is 22. So 6736, this is 6736 plus 22. That is 8, that is 5, that is 7, that is 6, 6758. So 1 minus 0.6758. And let me grab my calculator. So 1 minus 0.6758. This comes out to be 0.3242, 0.3242. And then round it off 3 to 4, correct to 3 significant figure. So all these steps need to be shown. Now the next part, explain whether it was necessary to assume the population of the mass of these rocks is normally distributed. What is the answer? For this one, it was not necessary to assume that the population is normally distributed, Why? Because the sample size is large. Because the sample size is greater than or equal to 30, therefore CLT applies. That is the knowledge that is used over here. Now let me copy this. Let me add another page and let me solve the hypothesis over here. Now it says that a geologist suspects that the rocks in another area have a mean mass which is less than 14.2. A random sample of 100 rocks in this area had a sample mean of 13.5. Assuming that the standard deviation is also 3.1, test at the 2% significance level whether the geologist is correct. So now let me make 4 regions. The first region, and then the second one, and then the third one right over here, and then the fourth one over here. So the first step that you need to write, step number 1, that is X bar follows a normal distribution. What is the mean over here? 14.2. What is the standard deviation? 3.1 square. Now the sample size is 100. The sample mean is already given. That is right over here, 13.5. So whatever you find out, just highlight that. So I found out I have used 13.5. That's over here. I have used 14.2. That's over here. 100 is used. And then 3.1 is used. You have to use everything. Test at the 2% significance level. So first of all, let me write over here 2% significance level. And in step 2, I'll be writing H0 and H1. H0, mu is 14.2. H1, it says mu is less than 14.2. have a mean mass which is less. So again, the word less is also used. That is over here. 2% is also used. That is over here. And we just use the 2% Z value from the table. That is 2.054. Now comes step number 3, which you have to do the calculation. That is Z is X bar minus mu sigma square over N under root. That is 13.5 minus 14.2 divided by 3.1 square over 100 square root. And definitely this will come out to be negative. Let me grab it from here. So this negative value is negative 2.258. So this is 2.258. Now what I need to do, I think I'm just looking for a normal distribution curve. There it is. And it's a lower tail test. So let me mark this region over here. That is a lower tail test. And what is the percentage? 2%. What is the Z value? Negative 2.054. What about this value? 2.258 with a negative sign. Over here is 0. That means this value is right over here. So Z calculated value lies in critical region. Therefore, reject H0. Therefore, accept H1. Therefore, right in the context of this question, do we have sufficient evidence? Yes, we have sufficient evidence to accept the theory or the claim that mean mass or weight, I think it's a better word, mean weight of rocks in this area is lesser than 14.2 kg. Let's first look at the mark scheme. The evidence, yes, there is evidence at the 2% level. Did I say 2% level? I should say. There is sufficient evidence at 2% level. Should mention this. So that the mean mass in this area is lesser than 14.2. So this is all good, all clear. And this is the working from last year. So now the rock question is all done, all clear. This is a two-tail test. So again, let me pause the recording and you people should try it out. So now let's look at this question. It says last year, the mean level of a certain pollutant in a river was found to be this much grams per milliliter. This year, the levels of pollutant X gram per milliliter were measured at a random sample of 200 locations in the river. The results are summarized below. N is 200, sigma X is there, sigma X square is there. First part, that is calculate unbiased estimate of population mean and variance, and then test at the 10% significance level whether the mean level of pollutant has changed. Now, first of all, what we do is that I'll write X bar, that is sigma X over N, which is 6.7 divided by 200. I'll just use it. And then I'll calculate sample variance, which is sigma X square over N minus X bar square. And this is 0.2312. 0.2312 divided by 200 minus X bar, which is 6.7 over 200 square. So now, whatever this value comes out to be, let me just go to the mark scheme. First of all, this is 0.0335. So let me write over here 0.0335. And this value, the unbiased estimate, it's N over N minus 1 sample variance. This is coming out to be how much? This is coming out to be 1, 2, 3, 4 zeros, 3392. 1, 2, 3, 4 zeros, 3392, which will become 0.0000339, correct to 3 SF. And this is also 3 SF. So that is unbiased estimate. This is unbiased estimate of mean, and unbiased estimate of population mean is the same thing as sample mean. So this is 0.03353 significant figures. So let me highlight these two. So this is unbiased estimate of population mean, and this is unbiased estimate of population variance, that is sigma square with a heart. Now it says test at the 10% significance level whether the mean level of pollutant has changed. So let me add a page over here and let me work on it. So now, first of all, the very first thing that needs to be done is making these tables. So that's the first one, that is the second one, and that is the third one. And the last one. I always miss out one of these. Okay. So now step number one. First of all, does it say it follows normal distribution? No, it does not say. So first of all, let me write it. Sample size is large. Therefore, CLT applies. So X bar follows a normal distribution. Which mean will we use? We should be using this mean, 0.034. 0.034, that is the mean. And population variance is unknown. So if it's unknown, it's not given. Therefore, use unbiased estimate of pop variance. What is unbiased estimate of pop variance? 0.0000339. 0.0003392 divided by the number of sample is 200. So that's the first box for normal distribution. What about the sample mean? Sample mean was just calculated. That is 0.0335. That is 0.0335. And let me write this thing as 0.0340. And this point, I'm just making it obvious. Now, too many decimals are over here. H0 and H1. H0, H1. Mu is 0.0340. H1 mu does not equal to 0.0340 because we are not sure whether the mean level has increased or decreased. The word is changed. It could be the greater one. It could be lesser one. This is 10% significance level. And also write that this is a two-tailed test. And let me grab that normal distribution table. Let me place it over here. And over here, let me write 5% at this corner, 5% at this corner, 5%, 5%. Therefore, the Z value is negative 1.645, positive 1.645. We read the table for 95% and then we apply it to both sides. Now, the calculation that needs to be done, Z is X bar minus mu sigma square over N under root. That is, this is X bar, 0.0335 minus 0.0340 divided by 0.0003392 over 200. Don't forget the square root. Simplify and use the mark scheme. So this value is coming out to be negative 0.1214. Negative 1.214. Not 1, yeah, 1.214. Okay. And this is the range. Compare with this value. Where does it lie? So this value lies just outside of critical region. So Z calculated value does not lie in critical region. Therefore, what's the conclusion? Do not reject H0. In other words, we are accepting H0. Why are we accepting H0? Because there is insufficient evidence at 10% significance level. Do mention the percentage that what is the pollution level? The mean level of a certain pollutant. The pollutant, the mean pollutant level. So do write mean pollutant level has changed. So that is what I've written. No evidence that the mean pollutant level has changed except H0 if correctly defined. All good, all clear. So now let me try out this particular question. A very nice question. Just go through it, try it out, and then I'll tell you the solution. Take around 3 minutes. Let me pause the recording. Let's look at this question. It says the manufacturer of a tablet computer claims that the mean battery life is 11 hours. A consumer organization wished to test whether the mean is actually greater than 11 hours. They invited a random sample of members to report the battery life of their tablets. They then calculated the sample mean. They are explaining the whole process of how sampling is done, how hypothesis is done. Unfortunately, a fire destroyed the records except for the partial document. Sample size is gone, it's unknown. And then what do we have? We have the sample mean 11.8. Is the result significant at the 5% level? Yes. Is the result significant at the 2.5% level? No. Now it says, given that the population of battery lives is normally distributed with standard deviation 1.6, find the set of possible values for sample size n. So technically, it's not a hypothesis question as such. It's more about finding the value of n, finding the set of possible values of it. Now we know that for 95% probability, the z value is 1.645. For 97.5% probability, the z value is 1.96. Let me grab a normal distribution table and let me place it over here, and let me explain to you how we can use these values. Now, first of all, let me mark this value over here as 1.645. That is corresponding 95% on the left, 5% on the right, the 5% critical region. And 97.5% on the left, 2.5% on the right, the 2.5% critical region. So this is 1.645. This is 1.96. This region over here, that is the region between which the test is significant and insignificant. So now what we can do is that we have the formula for z, which is x bar minus mu sigma square over n under root, which can also be written as x bar minus mu sigma over root n. And let me plug in different values of z. If z is 1.645, so I'll write 1.645 as x bar. Where is x bar? That is right over here, which is 11.8. So x bar, let me write over here, that is 11.8. And how much is sigma? That's right over here, which is 1.6. And what else do we need? I think that's pretty much about it. And definitely this is mu, which is 11. So mu is 11. So 11.8 minus 11 divided by sigma divided by root n. So this is 1.645, this is 1.8, and after the flipping, this is root n over 1.6. So therefore 1.645 into 1.6 divided by 1.8. So this will give me the value of root n, and hence I can find n. Similarly, let me use z as 1.96. Therefore 1.96 is 11.8 minus 11 divided by 1.6 over root n, which again is 1.8 into root n divided by 1.6, and therefore 1.96 into 1.6 divided by 1.8, that gives me root n. So we are getting two values of root n. One of the value is coming out to be 15.4, that is this value. The other value is coming out to be 10.8, that is this value. Now, the value of sample mean lies between 10.8 and 15.4. But we know that the number of sample, that is n, it has to be definitely an integer. So let me draw a number line. Let me mark over here 10.8, and then I have integers 11, 12, 13, 14, 15, and somewhere here is 15.4. It's not drawn to scale. What are the integer values that lies in between? These are the 5 integer values, and that is exactly what they are looking for. They are looking for set of possible values for sample size n. All you have to do is to make sure that you write it as an integer. So that is all from my side from Mathematics with Shahab Yaqub, and that was about S2, hypothesis test, and it was about normal distribution, or it was about CLT and a lot of unbiased estimates, and we dealt with a one-tail test and also a two-tail test, and that's how hypothesis is supposed to be done. Stay tuned for more content on Mathematics with Shahab Yaqub.